topic, that is CPM, critical path method. So CPM, this is critical path method. So in CPM analysis we consider only one time estimate, that is average duration of the project, and based on this we go for calculation, but again this depend on 4 time estimate of the activity. So let us see. So in CPM only one time estimate, average duration of the project is given, and based on that analysis is done. So this is tail node, this is head node. So average time estimate I to j is given, and based on this analysis is done. This is further depend on 4 time estimate, this further depend on 4 time estimates of an activity. So first one is earliest start time. Earliest start time means the earliest occurrence time of an event where the activity originates. So earliest start time is always calculated at tail node, and this refers to the earliest occurrence time of the event where the activity arrow originates. This is denoted by ES I to j. So this ES I to j is the T of I, means earliest time estimate of the part analysis. So T of I, this is the earliest start time. Now second one is earliest finish time or earliest completion time. So second one, earliest finish time. Earliest finish time, this time refers to the sum of earliest start time of an activity and the duration of the activity, and this is denoted by E suffix F. So this refers to the sum of earliest start time and average duration of an activity. It is denoted by earliest finish I to F. So this is the sum of EF I to F. This is sum of earliest start time plus average duration of the project. So this can be written as T of I plus T of I to j, earliest finish time. This is I to j. So this is earliest finish time. Next one, third is latest start time. Before that, we have to go to latest finish time. So first we will see latest finish time and then we will go to latest start time. So latest finish time. Latest finish time is the latest occurrence time for an event where the activity arrow terminates. So this time refers to the latest occurrence time of an event where the activity arrow terminates. It is denoted by LF I to j. So LF I to j is the TL of j. Now we will come to latest start time. So latest start time is the difference between latest finish time and average duration of the project. So this is the difference between latest finish time and average duration of the project. So this is latest start time I to j. This will be latest finish time minus average duration of the project. So in this way we have estimated all 4 time estimates, and based on this the analysis is done. So one important term comes, that is float, or sometimes it is called as total float. Float or total float, this is equivalent to slack in part. So this is slack in part. So this total float or float is defined as the amount of time by which a particular activity can be delayed without affecting the time schedule of the network. Therefore, since the slack refers to event and hence it is used in part, on the other hand float refers to activity and therefore it is used in CPM. So let us note down. Float or total float refers to the amount of time by which a particular activity can be delayed without affecting the time schedule of the network. Since the term float refers to activity, so it is used in CPM, and this is defined as the difference between maximum available time to perform the activity and activity duration time. So it is defined as the difference between maximum time available to perform the activity and average duration of the project. So float is the maximum available time minus duration of an activity. So maximum available time is the latest finish time minus earliest start time. So this is the maximum available time for a given activity, and duration time is the average time estimate. Therefore, the LF can be written as TL of J minus ES can be written as T of I minus T of IJ. So this can be rearranged as follows: TL of J minus T of I into J minus T of I. So this can be written as LS I to J minus TE of I. So this can be written as LS I to J minus ES of I. So both can be written as float. So both are definition of float. Anyone can be used. This is one of the important lesson. And the last one is the critical path. The activities having zero float or total float are called as critical activity, and the path of the critical activity is called as critical path. So the activities which have zero float or total float are called critical activities, and the path of the critical activities is called as critical path. So let us take one problem and then we can appreciate the method. So let us note down the question. Obtain critical path of the project using CPM for the following data. So activities, and second one is average duration. Activities is 1 to 2, 2 to 3, 2 to 4, 3 to 4, 3 to 5, 3 to 6, 4 to 5, 4 to 6, 5 to 6. So average duration is given as 3. This is 3. This is 2, 0, 3, 2, 7, 5, 6. So in case of CPM analysis, first we have to draw the network. So let us draw the project network. So let us draw the project network. So project network is as follows: 1 to 2, then 2 to 3 and 2 to 4 is there. So 2 to 3, 2 to 4. After this, 3 to 5 and 4 to 5, 3 to 5, 4 to 5, and then 5 to 6. It is also written 3 to 6. It is also written 4 to 6. Now average duration of the activities is given. So this is 3, this is 2, this is 3, this is 3, this is 7, this is 5, this is 6, this is 2. So let us draw. So first we will take t as 0. This t will be 0 plus 3. This t will be 3 plus 2, 5. This t will be 3 plus 3, 6. Here it will be maximum. So 5 plus 7 it is 12 and 6 plus 3 it is 9. So we'll take maximum. This is 12. Add this again, maximum of all. So this is coming 8. This is coming 18. This is coming 10. So we'll take maximum. So it is coming 18. In this case we have left one part, that is 3 to 4. Since average duration is 0, this means it is a dummy activity. So one mistake this has done. So this is 0. So whole thing will change. This is 0, this is 3. This will be 3 plus 2, 5. Again, this will not be 5 because this will be maximum of 3 to 4 and 2 to 4 and 3 to 4. So this is 6. So this will be 6 plus 0, 6. This part will be 6 plus 3, 9, and 6 plus 7, this will be 13. Then this part will be maximum of 13 plus 6 or 6 plus 5 or 6 plus 2. So this will be 19. This is sorry for the mistake. This will be 19. Again the project completion time is not given. So this will take TL as 19. Now we'll go for back calculation. So first we'll come to 5. So this part TL will be 19 minus 6. This will be 13. Now I'll come here. This will be again minimum of these two. So 13 minus 3 and 19 minus 2. So this is 17 and 1 is coming 10. Again we have to take from 4 to 3. So again we cannot calculate here because 4 is not whole. So first we will go to 4. So calculation of 4, this is 13 minus 7 and 19 minus 5. So minimum is 13 minus 7, that is 6. So here we will take TL as 6. Now we can calculate. So TL will be 6 minus 0 is 6 or 13 minus 3 at 10. So minimum is 6. Now for 2, this is 6 minus 3 or 6 minus 2. So minimum is 3. Now again here the TL is 0. So based on this, since we have to calculate the critical path using CPM analysis, so we will calculate total float or float. If it was fault analysis, so we have calculated slack at various points and we have calculated the critical path. But since it is a CPM analysis, so we have to find out total float. So let us calculate the total float. So let us calculate total float. So first we will write activity. This is 1 to 2, 2 to 3, 2 to 4, 3 to 4, 3 to 5, 3 to 6, 4 to 5, 4 to 6, and 5 to 6. So first we will take average duration. This is T of ij. Then second one we will take earliest start time. This is T of, then we will go for earliest finish time. So this is column number 1, this is column number 2, this is column number 3. I will go for latest or earliest finish time. So we will go for earliest finish time. So this can be calculated by adding column 2 plus 3, because earliest start time plus average duration of the project is earliest finish time. Then we'll go for latest start time and latest finish time. So latest start time. So latest start time, and this is latest finish time. So first we will calculate latest finish time, and this will give float or total float. So first we will calculate, this is column number 4. First we will calculate latest finish time. So this will be given as TL of j. This will be column 6. Now latest start time can be calculated from latest finish time minus average duration of the project. So this will be 6 minus 2. This will be column number 5. And now at the last, float or total float will be difference of latest start time and earliest start time as said in the calculation. So this total float will be column 5 minus column 3. So let us calculate. So average duration of the project is given as 3, 3, 2, 0, 3, 2, 7, 5, 6. Now earliest start time we can calculate from T of all the event. So 1 to 2 is, so T of I, so this is 0. Then 2 to 3 T will be 3. Then 2 to 4 again T will be 3. We have to take at initial point. So 1, 2, 2 like this we have to take. Now 3 to 4 we have to take on 3 here. So T is 6. 3 to 5 again 6. 3 to 6 again 6, because we have to take on 3. Now 4 to 5. So T will be again 6. 4, 6. Now at point 5 it is 13. So we'll take as 13. Now earliest finish time, this will be sum of earliest start time plus average duration of the project. So both will add. It will be 3. This will be 6. This will be 5. This will be 6. This will be 9. This will be 8. This will be 13. This will be 11. This will be 19. Now to calculate latest finish time, again we have to go at the TL of head point. So 1 to 2 we have to go for 2. So this is 3. For 2 to 3 again this will be at point 3. This will be 6. For 2 to 4 this will be at 4. So this will be 6. For 3 to 4 we have to go at 4. So this is 6. 3 to 5 we have to go at 5. So this is 13. 3 to 6 we have to go at 6. So this is 19. 4 to 5 we have to go at 5. So this is 13. 4 to 6 we have to go at 6, so this is 19. 4 to 6 again 19. Now to calculate latest start time, we have to subtract latest finish time from the average duration of the project. So this will be 3 minus 3, this will be 0. This will 6 minus 3, this will be 3. 6 minus 2, this will be 4. This is 6 minus 0, this will be 6. 13 minus 3, this will be 10. 19 minus 2, this is 17. 13 minus 7, this is 6. 19 minus 5, this is 14. 19 minus 6, this will be 13. Now to calculate float or total float, we have to subtract latest finish time from the earliest start time. So this will be 0. This will be again 0. This will be 1. This will be 0. This will be 4. This will be 11. This will be 0. This will be 8. This will be 0. So the activities having 0 float or medium float will give the critical path. So we can write critical path can be identified from this. The medium is 0. So we can write critical path is 1 to 2, 3, 3 to 4, 4 to 5 to 6. And critical activities are one to two, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. And average duration of the project will be this. This is the latest finish time. So average duration of the project this will be 19 units. There are two more points which need to be discussed. One is free float and another is independent float. So let us see. One is free float. Free float, this is based on the assumption that all the activity starts as early as possible, and this is the difference between available time for an activity and to the average duration. So this is based on the assumption that all activities start as early as possible. So this is activity I, this is event I, this is event J. So this T of I, this will be T of J. This will be average time duration. So this free float or F I to J will be maximum available time minus average duration. So maximum available time, since we have assumed all activity start as early as possible, so maximum available time will be T of J minus T of I, and minus average duration, this will be T of I minus J. So this will be free float. Let us take one example. This is event 1, this is event 2, this is given as t equal to 5, average duration is 10, so this is given as 17, this TL is given as 19, this TL is given as 16. So for this we have to find out free float. So maximum available time will be 17 minus 5, assuming that all activities start as early as possible. So free float of 1 to 2 will be this TE of j minus TE of I minus average duration of the project. So this T of j is 17, this is minus 5, and average duration is 10. So this will be 12 minus 10. So free float is 2. So this we have assumed that all activity start as early as possible, and after that we have calculated free float. Now let us see independent float. So now next is independent float. So independent float, this is based on the assumption that predecessor event occur at its latest possible time and successor event occur at its earlier possible time. So this is based on the assumption that the predecessor's event occur at its latest possible time and the successor event at its earliest possible time. So let us take, this is the event I, this is the event j, this is the average duration I to j. So this will be T of I, this will be T of j, this will be TL of j, this will be TL of I. So the independent float can be written as again this will be maximum available time minus average duration of the project. So maximum available time minus average duration. So maximum available time assuming predecessor's event occur at its latest possible time and successor at its earlier event time. So the maximum time will be T of j minus TL of I minus T of I minus j. So we will take one example and then we can understand. This is event 1, this is event 2, this is given as T as 5, here it is given as TL as 6, average duration is 10. So T is given as 17, TL is given as 19. So we have to find out independent float. So independent float, this can be written as T of j is 17 minus TL of I, this is 6, minus average duration of the project. Average duration of the project is 10. So this will be 11 minus 10. So independent float will be 1. So in this way we can calculate this is independent float. So this is independent float. This will give independent float 1 to 2. In this way we can calculate independent float. So after having this analysis, we can say that part is probabilistic system, on the other hand CPM is deterministic system. That's why while making a model, the part and CPM can be written as this follows. The area of the curve is more, this is for part. On the other hand, this is for CPM. This is for CPM. So part is probabilistic system, this is deterministic system. So in this way, in a nutshell, we have used both PERT and CPM analysis for calculating the network duration project as well as all the critical activities. So in this way, this topic is concluded, and this topic carry approximately 5 to 6 marks in the gate examination.